Salam everyone! In the last episode, we explored the concept of time series stationarity. Today, we'll dive into key statistical measures used in time series analysis, variance and covariance. Before we dive into today's topic, I have an exciting update for you. Starting with this episode, you will find a link in the description to a GitHub repository containing hands-on notebook examples. It is a great way to deepen your understanding and practice what we discuss. Let us get started. Variance. Variance is a statistical measure of how far each value in a dataset is from the mean. In other words, it reflects the overall variability within the dataset and shows the spread of a dataset points around its mean. This metric is widely used in various fields, including finance, where it helps determine the volatility of a market or the stability of a security. Variance is often represented by the symbol sigma square. It is calculated by taking the differences between each number in the dataset and the mean, squaring the differences to make them positive, and then dividing the sum by the number of values in the dataset. Typically, variance isn't used on its own. Instead, it is often a step in calculating the standard deviation of the dataset. The standard deviation, or sigma, is found by taking the square root of the variance. You can easily calculate the standard deviation using NumPy library as demonstrated in the attached notebook. One notable drawback of variance is its sensitivity to outliers, values that are significantly far from the mean. Since variance involves squaring those deviations, outliers are given extra weight, which can distort the analysis and skew the results. In the first plot, we have a time series without outliers, where the variance is around 20. However, after introducing a few outliers into the same time series, you can see that the variance increased from 20 to 40. In this example, I'm using NumPy library to calculate the variance. You can see the full example in the attached notebook. When we talk about variance, another metric often comes to mind, which is covariance. While the two share similarities in their names, they serve different purposes. Variance measures the spread of a single dataset around its mean, whereas covariance measures the directional relationship between two random variables and how they change together. Let us take investments return as an example. A positive covariance means both investments returns tend to move upward or downward in value at the same time. An inverse or negative covariance, on the other hand, means the returns will move away from each other. When one raises, the other one falls. If the covariance value is 0 or close to 0, it suggests there is no strong relationship between the two investments' returns. Covariance is commonly represented by the symbol cov(xy), where x and y are two random variables. The formula for covariance is the following. It is calculated by summing the multiplied differences of each data point from the mean for both variables x and y, then dividing the result by the number of data points minus 1. That's it for today. In the next episode, we will dive into a key statistical measure used in time series analysis, correlation, and we will talk about its relationship with covariance. If you have any questions or feedback, feel free to share them in the comments below. Stay tuned and I'll see you in the next episode. Salam.